Have you ever seen a liquid change color right before your eyes? It looks like magic, doesn't it? Well, science can be just as magical as a wizard's potion. Today, we're diving into the fascinating world of color-changing chemical reactions. We're gonna explore acids, bases, and indicators. So put on your safety goggles and get ready for some mind-blowing science. Okay, so what's actually going on when these colors change? It all boils down to chemistry and how different substances interact. Everything around us is made up of tiny particles called molecules. When we mix certain chemicals, we're rearranging these molecules, which can change how the substance interacts with light. Light is made up of all the colors of the rainbow. But when it hits an object, some colors get absorbed and some get reflected back. The color we see is the color that's being reflected. In a color-changing reaction, the chemical reaction changes the way the molecules are arranged, altering which colors of light are absorbed and reflected. Imagine it like this. Before the reaction, the molecules reflect blue light. After the reaction, they reflect red light instead. Pretty cool, right? Now let's talk about one of the most famous color-changing reactions involving phenolphthalein. Think of it as a chemical detective that tells us whether a solution is acidic or basic. Acids like lemon juice taste sour, while bases like baking soda taste bitter. But we don't want to go around tasting everything, do we? That's where phenolphthalein comes in. When added to a basic solution, it turns a bright, vibrant pink. In an acidic solution, it stays perfectly clear. It's like magic, but it's really just chemistry at work. Phenolphthalein is used in all sorts of applications, from testing the pH of swimming pools to conducting experiments in the lab. It's a great example of how a simple color change can tell us a lot about the chemical properties of a substance. You don't always need fancy chemicals to see amazing color changes. Sometimes nature gives us the best tools. Take red cabbage, for instance. This ordinary vegetable is actually a natural pH indicator. Hidden within those red cabbage leaves is a pigment called anthocyanin. This pigment changes color depending on the pH of the solution it's in. In an acidic solution, it turns a vibrant red like cranberry juice. Add it to a neutral solution and you'll get a beautiful purple hue. In a basic solution, anthocyanin transforms into a brilliant green. And if the solution is very basic, it can even turn yellow. You can use red cabbage juice to test the pH of all sorts of household items. Have you ever wished you could make gold appear out of thin air? With chemistry you can do something pretty close. It's called the golden rain experiment. This experiment involves two chemicals, lead-2 iodide and potassium iodide. When these two chemicals are mixed together in a hot solution, something amazing happens. The solution turns a clear yellow, but as it cools down, tiny golden crystals start to form and fall to the bottom of the beaker like a shimmering rain shower. These golden crystals are actually lead iodide, and they form because lead iodide is less soluble in cold water than in hot water. As the solution cools, the lead iodide molecules start to clump together, forming those beautiful, shimmering crystals. The golden rain experiment is a classic example of how temperature can affect solubility and lead to the formation of crystals. Ever wonder how traffic lights change colors so seamlessly? We can recreate that same color-changing magic in the lab with a reaction that mimics those familiar red, yellow, and green signals. For this experiment, we'll need a few key ingredients: glucose, sodium hydroxide, indigo carmine, and a bit of water. First, we dissolve some glucose in water. Then a pinch of indigo carmine is added, giving the solution a beautiful greenish hue. When we add a bit of sodium hydroxide, the solution undergoes a fascinating transformation, changing colors as we shake it. It shifts from green to red, just like a stoplight. This happens because the sodium hydroxide helps the glucose steal electrons from the indigo carmine, causing it to change color. As we continue to shake, the solution gradually returns to its original green color, completing the traffic light cycle. From the vibrant pink of phenolphthalein to the shimmering gold of the golden rain experiment, we've seen firsthand how chemical reactions can create a kaleidoscope of colors. Scientists use color-changing reactions to track the progress of chemical reactions, test for the presence of specific substances, and even develop new medicines. So the next time you see a color change, whether it's in a lab or in your own kitchen, take a moment to appreciate the amazing chemistry that's happening right before your eyes. Which experiment was your favorite? Let us know in the comments, and don't forget to like and subscribe for more amazing science videos.